you, sir?
Very good, thank you. Long time no talk.
Yeah, it's been a while. Been a while. Thanks for having me back to the user group.
Absolutely, always a pleasure to have you. Wanted to ask you, are you using a Mac or a PC?
PC.
PC. Very good. Okay. Um, we got 21 people that RSVP'd, and more are trickling in. And I just started the live stream on YouTube, so we should be getting a lot more people trickling in. Um, if you're ready to get started, we can. I can start the recording and do the introduction.
Yeah, yeah, absolutely.
Excellent.
This conference will now be recorded.
Good evening, everyone, or good afternoon, depending on where you're joining us from. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group if you're joining us for the first time. We meet typically every second week of the month. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, whether it's infrastructure as a service, platform as a service, or software as a service. You can find all meeting information for past meetings as well as future meetings posted on meetup.com at the link listed at the bottom of the slide. We'd like to give a big thank you to our sponsors, the .NET Foundation for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space as well as the recording. Some general information, please keep in mind participation is encouraged, and like I always say, the only stupid question is the one not being asked. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized. The meeting is open to all levels of expertise, whether you're a hobbyist, a student, or a working professional. So feel free to jump in at any point in time with a question or a comment. And at the same time, we want to give our presenter enough time to go through the slides and the demos. Lastly, the presentation is being recorded and will be posted on YouTube. So for tonight's feature presentation, we have Jeff Palermo. Jeff joins us from Clear Measure in Central Texas. He is the CEO of the company, which is one of the fastest growing small businesses in Central Texas. It is the go-to software engineering firm for mid-market B2B companies. Jeff has been a speaker at national conferences such as Microsoft Ignite, TechEd, Visual Studio Live, and DevTeach, just to name a few. He's also the founder of several user groups, author of multiple books, videos, and articles. And he's also a graduate of Texas A&M, despite myself being a Buckeye fan, but we'll let that one slide. He's also a graduate from the Jack Welch Management Institute. In addition, he's an Eagle Scout and an Iraq War veteran. Thank you for your service. And in his spare time, he likes to spend time with his family, camping and riding dirt bikes. And so with that, Jeff, the floor is yours.
Fantastic, fantastic. Well, let me do the share screen and get it switched over. Pleased to be back at the user group. Let's make sure that we can. Where is this? Screen one. There we go. And share. All right, it should be coming through.
Looks good.
Fantastic, fantastic. So I won't go through the introduction because Sam just did it, but I've been programming for a living, working at it since 1997, and been loving it ever since. And I've been in the consulting world since I think 2006. So kind of I did a stint at Dell Computer Corporation, seeing the inside of a massive IT organization, and then been consulting for almost 20 years. And consulting is kind of like working in dog years, where you see so many different environments, so many different companies in one regular year, that I've really enjoyed the perspective, because I can not only analyze a problem, but I can see trends that that I can see that multiple organizations, think a certain way or maybe struggle with some things while other things tend to fall into place nicely, and get some sort of sense for how it is around the industry, and just have done so much teaching and speaking that I've fielded so many questions from audiences where it also helps me with a good perspective of just the types of things that different people think about. And the best way, it's an old quote, I don't know who says it, but one of the really good ways to learn something is to be forced to teach it, because it forces me to figure out how I want to articulate a concept so that I can convey some meaning that makes sense to multiple. And as it is today, literally, uh, this past Monday through Wednesday, I just finished a 3-day intensive software engineer and architect boot camp class in person in Austin, Texas. We had a beautiful facility at the Lakeway Resort and Spa conference room, kind of overlooking Lake Travis, and we had lots of good rain, so the lake was beautiful, and 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 we had a lot of really experienced engineers and architects, and I was able to train them. And one of the days was nonstop AI. And so I've given this presentation, AI driven development, quite a few times to various audiences, but I'm really excited about this audience because there's some things that I figured out how to describe, just fresh off of that experience and fielding some new questions that I think even strengthens this presentation here. So I'm really excited, and I'm pleased to be here. Um, our agenda, our agenda has two pieces, and this is how I think about AI when it comes to .NET software development. And on one side, we are getting ideas and figuring out how to create software that uses generative AI, that uses language models. But on the other side, we're also figuring out how to use generative AI to just create software like GitHub Copilot and Cursor and JetBrains AI Assistant and DevExpress, CodeRush, and so many other tools that are coming about and competing with each other using generative AI to create software. So I want to talk about those two separate things because they're completely different angles that we work with, and yet they're using the same underlying technology. The transformer architecture that is the basis of GPT, generative pre-trained transformer, and the large language models that have come about, and even the small language models, to the point where the first L in LLM has started to be less meaningful, because we have a lot of scenarios that don't necessarily need a large language model. We just need some language models. And as they've come around, there's so many that have different capabilities. Um, if you're not familiar, I wrote my latest book that came out just late last year, and it's called The Five Pillars: Leadership for Effective Custom Software. And it is a book with zero code. So it's my fifth book that I've written, but it's the first book that actually doesn't have any code. I've written multiple books in the ASP.NET and MVC era, and I wrote a book in .NET 2019, .NET DevOps for Azure, which is all about how to structure and implement a complete automated DevOps environment for your .NET applications targeting Azure. And this one is about software leadership. And so you can look at the URL, go to the URL, go anywhere books are sold. But I also, I'm not an author for a living, and so I'd really like to just help people out and get this into the hands for as many people. So I can send electronic copies till the cows come home. So if you'd like an electronic copy, I'd be more than happy to send one to you. So you can just request that, send me an email. All right, getting into artificial intelligence just as a concept. Um, it's important to understand where it's come from and the types of things that have transpired along the way. It's kind of like using the old adage: if you don't understand history, then you don't understand the present. Well, in artificial intelligence, it really helps to understand the history of it so that we can process, the present, and then so that we can basically decide how we want to think about the future. So 1956, a gentleman named John McCarthy made a pitch to the university for some funding for a summer program. Effectively, they needed some food and water and lodging, so they needed a little bit of funding just to do some research over a summer program. And he gathered together some researchers from Harvard, IBM, Bell Telephone, and he formed a study group around a hypothesis, and he coined the definition AI, artificial intelligence, and he said that literally AI is the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. And lo and behold, when we come back to the present, we are in fact still doing that. We still are precisely describing features of human intelligence, and we are making machines that can be made to simulate it. And ChatGPT came out in 2022, and everyone was so amazed that they instantly started trusting it as if it had some actual intelligence instead of artificial intelligence. And a lot of people have gotten into trouble. You've heard of lawyers filing legal briefs that had absolute factual inaccuracies about other cases, and getting sanctioned, and their careers threatened, because they thought that they were querying Google, which brought them back maybe actual things. Whereas what we found is that the language models today, there's no actual understanding, there's no actual awareness, there's no actual creativity, and there's no actual understanding, there's no actual knowledge. What there is artificial simulation of the formulation of words that could simulate what an intelligent human might do. And we end up anthropomorphizing or personifying this technology accidentally, and and then because we've done that, we use the term hallucinating as if it's some intelligent robot that's supposed to not hallucinate. So all of you have probably run some experiments. I've run some experiments just asking some questions about my own book, The Five Pillars, and I said, hey, show me the table of contents or list it out. And guess what? It showed me a 13 chapter table of contents for my book. Well, the problem is my book has 12 chapters. And I looked at its table of contents, and none of the chapters were the actual chapters. And so the prompt might as well have been, Jeffrey Palermo wrote a book called The Five Pillars Leadership for Effective Custom Software. If Jeffrey Palermo wrote the book on that topic, what might the table of contents be? And then it just makes something up. So I'm going to get back to that and why that is a little bit later, but I want to talk about some of the tooling just to get started. And if you're already on this, that's great. If not, then you'll want to make sure that you can do that. Let me just get. Actually, I want to move something out of the way real quick. Okay, so you want to make sure that you have Olama and LM Studio. I'll talk about that in a little bit. But there's some GitHub repositories that you can use that I think will be helpful. They're both on GitHub, and the URLs are on the screen. GitHub.com/Jeffrey Palermo/AI Semantic Kernel. And that is a in-unit test library with some different test cases that illustrate some of the capabilities of the semantic kernel libraries, and they they literally can showcase some of the capabilities. The other one is Bootcamp-Palermo-Work Orders, and that's an open source app that I use for teaching. And it also has in it, baked into the application, some examples of some .NET agents that do some probabilistic determinations on whether some actions are appropriate or not, and also some examples of some GitHub Copilot prompts that can be fed into GitHub Copilot agent mode, and then you have some pretty good significant output. I will mention something that you might want to look at the bootcamp code base on, and that is some of the design patterns that are in the application. I'm kind of getting ahead of myself, but when you use GitHub Copilot for AI driven development, you are going to get more code similar to the application that you already have. And if you don't like the code base that you're working with in front of you, then you're not going to like the code that Copilot generates for you. But if you do like the design patterns that you already have, and you do like the code base that you already have in front of you, then Copilot agent mode is going to give you more code like that, and you're going to be more likely to appreciate it. All right, so getting your computer set up, I mentioned LM Studio and Olama. You want to have both of those running, and it's very simple. Command line. If I just open up a terminal window, and I'm just going to pull it over on top of the slide and blow it up like that, and I'm going to say Olama list, and this is going to show I have Olama running. It's command line tool, and it's going to not responding, timed out. Okay, that's because I probably don't have it actively running. Let me start up the background daemon and let me try that again. Okay, is Olama started now? Let me check. Check it on the other screen. Don't, might not be. Oh, there's an update. Okay, all right, well, uh, then I won't show you interactively. But it's a pretty easy next, finish, and you can download open source models. Llama 3.2 is a very common one that can run on most computers, and LM Studio can do that as well. And there's a plethora of open source models that you can use in order to run it locally. When you're running it locally, you'll want to think about the hardware that you're running, and um, the NVIDIA RTX series is definitely the king of the hill, and I know the 50 series is out, but the 50 series is marginally faster than the 40 series, but you can see here that so many of these are much faster than the Intel NPUs that are being embedded in the latest i9 or the i series of processors. And even if let's say that you don't have one of these, you can get some external video cards and you can plug it in, and all the new ones come with it. But go to Tom's Hardware and look at this. But if you have a desktop computer, even a RTX 3070 is gonna be able to let you run these language models locally and get pretty far with investigating some of the capabilities and do some of the testing. All right, let's move on. Okay, so um, I want to talk about what a large language model server is, because a language model server is something that is a new architectural element that hasn't always been present. All right. Um, Let me illustrate with a software application, and I'm going to point with my mouse. Let's say we have a .NET application, and let's say that we have a client using SPA applications have this shape where in the browser there's a client and it's calling out to our .NET application. A lot of us are used to using SQL Server. Well, let's look at that. With SQL Server, regardless of where it's running, even Azure SQL Database, there is a .mdf file somewhere. That's the SQL Server data file. And we never open up that file and look at what's inside. We actually don't know the format of that file. There's no way to open it in Notepad and look at it, but that file is out there. And for most significant systems, that file is quite large. and we take backups of it and whatnot. So our application code is never going to reach out on the file system and open that. Instead, we run another piece of software that we call a database server. And this is SQL Server. And SQL Server reaches out to the file system and opens it up and manages that file. And so, what does our code do? Our code calls out to SQL Server. SQL Server needs a query. It needs a string that is formatted in a specific way. And if it receives a string that is formatted in a specific way, then it will look at what is in the database file and it will return another string that is formatted with some return data. And that return string has some specific structure to it. But our application code doesn't ever actually have to formulate the string that is the query going into SQL Server, and it also doesn't have to manually parse the string that comes back from SQL Server. Instead, we use libraries called Entity Framework and Dapper, and in the past we used in Hibernate. We use these data access libraries to help us formulate the entire query in the right way and then to interpret the response and to populate some of our C# objects that's running in our application. And that's just the way we've been doing it for the longest time. In fact, if it weren't SQL Server, it might be MySQL, it might be Oracle, it might be SQLite, it might be PostgreSQL, and the format of the SQL query needs to be slightly differently. But the libraries are structured so that our application code doesn't actually have to care about that. All those differences are handled for us. So I want to compare that with the architecture of what happens when we're using a language model in our application. So let's take a look at that. With a language model, there is a file that is on disk, and that file can be quite large, and that file is a model. We are never going to open that file with Notepad. We can't open that file and understand the format of what's in there. We don't need to know the format. We don't understand the format. Instead, there is a program that we run, and it's called the LLM server. Olama is one, LM Studio is another, and these are the LLM servers, and we run it, and it opens the file and it manages the file. Now, in the case of a model file, these files are read only. There is no updating like there is with the database file, so it's read only. All right, so this LM server sits there, and our application code calls out over the network, across, even if it's on the same computer, it calls out from the process that it's running in over whatever network address, and it calls to it and sends it a specially formatted string. In SQL Server, we call that special format a query, and in a LLM server, we call that the prompt. And Olama, in this case, is going to look at what's in the model file and is going to decide and formulate some type of response. The response comes back as a string, and then we use it. Well, actually, we don't use it. Our application code does not have to manually create that string prompt going in, and it doesn't have to manually parse the response coming back. Instead, we use libraries called Microsoft Semantic Kernel or Microsoft Extensions AI, and those, just like Entity Framework, helps us craft the prompt going over the wire and helps us interpret and parse the response coming back. And different models actually have different required prompt formats and different response formats. But the libraries, just like Entity Framework, help us to manage the differences so our application code can be the same. So I wanted to talk architecturally about that similarity so that you could figure out how it fits in your .NET application. And so the patterns that you use to encapsulate the dependencies with the database and Entity Framework, you can use those same patterns to encapsulate the code and the dependencies when you're talking to Olama or OpenAI or the Azure OpenAI service or Google's service or any of the others, because those are merely compute services. You don't actually have to back up this model file. You can just pull it again from the repository, and this is purely a compute service. So while the models are differentiated, the LLM servers are quite commodity. So I'm going to pull over LM Studio just for a second and show you. I've got the Quinn uh, the Quinn Instruct model open, and I'm just going to say, some basic chat instructions. Hi, how are you? How can I help you today? Give me a 10,000 word um, a poem. And here's here's a short and simple one. He didn't want to do it. Okay, that's too much for it. And of course, I'm on a instruct model. Uh, yeah, there it is. What's 2 plus 2? 2 plus 2 equals 4. So there it is. And I picked the wrong model for that. But every model has different capabilities. Now with um, LM Studio, one thing that we enjoy is being able to see the different runtimes. So we can see the CUDA runtime, and it looks like it's updating right now. The CUDA runtime versus the CPU runtime. If you don't have a CUDA-based processor, an NVIDIA RTX processor, then you'll probably, you'll definitely be using the CPU. I'm going to pull over Task Manager on my own computer, and we'll be able to see that I have RTX 3060 on this particular computer, and I have a few other GPUs, and of course the CPU. If I did not have, and actually before this computer had any kind of RTX GPU in it, I was using the CPU runtime, and I was really maxing out my CPU. It was running at 100% all the time, and it was dog slow. Whereas now that I have an RTX 3060, I can do quite a bit of processing, and it's very comfortable. So I just wanted to show that. All right, let me pull that over to the side again. Okay. And let's move on to the next one. All right. So I talked about Visual Studio and how to arrange um, the dependencies. So you see we have a data access library, and that's where all the code for talking to SQL Server is going to be. So if we're going to integrate a language model, then we're going to probably add in um, our Visual Studio solution the LLM gateway, and have those Microsoft Semantic Kernel or Microsoft Extensions AI, and that's where we would put it. Okay, so I'm going to show you a little bit of code for what an agent looks like, just to wet your whistle and jump right over. But let me see where I want to show. There we go. Okay, so let me just jump in. I'm going to close this down and make this code bigger. All right. This class in and of itself, if you want your application to use a LLM server, if you want to embed a feature in your application that makes use of generative API, and you select the model to use, and maybe you're doing some local testing with Olama, or maybe you're using Azure OpenAI and you've said, okay, let me use GPT 4.1, or maybe let me use GPT 4.0 mini. If you don't need a language model that's been trained with a very large corpus of information, basically the entire public internet, if maybe you need a language model that just maybe understands English, and you can get some good mileage by funneling into the data the information that's just pertinent, and maybe you can use a really small, inexpensive model to run. And so this scenario, this scenario is just that. Let me just talk through it. We have a class. Now, I have a sample work order application. And a work order application has statuses, and you can create a new work order. You can assign it to somebody, and you can um, run it through its statuses. Actually, let me let me show you the work order application. I think it's still running. All right, let me just go to the log out, go to the homepage. All right, here we have a work order application for the First Church of Springfield, and it is Simpsons themed. Okay. And the Reverend Timothy Lovejoy is the pastor. So let's log in. And it doesn't have any kind of security, but it has Maud Flanders, and it has Helen Lovejoy, it has Homer Simpson, Lisa Simpson, Marge, Mo Sizlak, Groundskeeper Willie. All right, so this is Simpsons themed. So I'm just going to log in as the Reverend Lovejoy, and we're going to create a new work order. Of course, I can see the different work orders that are in the system. Groundskeeper Willie has the assignment to prepare the church grounds for Christmas decorations. But let's create a new work order, and let's assign it to Lenny, and I'm gonna say you know demo something, and then description is a test work order, and I can save, and notice how I can see my new draft. And okay, if I can go back to the work order, and I can assign, and now to sign. So it has the workflow, um, and of course I can search by creators. I can search by assignees. I can search there, and it has basic workflow capabilities. All right, basic workflow capabilities. So let's say that I'm creating work orders, and it's been a long time, and I assigned a work order more than 24 hours ago, and it's just junk. I was just testing some things out, and I forgot, and it's just cluttering up the system. And I even put in some the room number. The room number is test. Well, I, as a human being, could go in there, and I could look for those. I could look for the work orders that are more than 24 hours old, and I could clean them up, and I could cancel them. Well, that's kind of a good scenario for an agent, because there's some type of human intelligence involved. And if we can make a machine simulate that aspect of human intelligence, then maybe we can automate a routine that automatically cleans up those work orders and finds them, locates them, and cancels them for us. So this is what an agent like that actually looks like in .NET. And by the way, this code base does use the newer Microsoft Extensions AI libraries, and some of the ones are still in preview. They're geared up for the .NET 10 era. If you need to be in production right now with one of these things, then you're going to want to use the Microsoft Semantic Kernel library. But all of those capabilities are getting moved over to Microsoft Extensions AI, just so that um, Semantic Kernel has very stable releases right now, whereas Microsoft Extensions AI has some things that are in flux. So in order to develop an agent, all you need to do is make a class. An agent can literally just be an object. In .NET, it can literally just be an object. And you basically need to use the single responsibility principle, one of the solid principles, just like you would design any other code. And so as we reason about this, let me close down this code. This class has one method, and it's async, and it returns bool. Should I cancel this work order? And it's being passed in the work order. So we have a background service that every now and then is waking up and is ripping through the different the different work orders, and we're passing in one at a time and asking the question, hey, should I cancel this work order? Obviously, if we just canceled every work order, then the system wouldn't be very interesting. And so this is a bit of human judgment, and we're making the hypothesis that says, if I use a language model, perhaps I can empower this particular .NET object to make the determination if I should cancel the work order. Now, based on the based on the criteria, I could make a series of queries and if statements if the criteria was it's assigned more than 24 hours ago, if the description contains a set of words, if the room number is uppercase test, but it's really hard to implement rules when the criteria is I want description to contain words like test or like demo or like temporary, or if the room number is similar to test. Well, what are the bounds of that? I mean, that's a broad thing. So this is where the power of the language model comes in. The language model has been trained in the English language. Now, could I use SQL Server SoundX, or could I use some other libraries to try to do something like this? Okay, I could try, but these language models are more powerful in language processing than so many previous generations of technologies. And so this type of probabilistic judgment is a great scenario for the language models. And how we implement it is basically by crafting the prompt. And probably all of you have heard the term prompt engineering. Well, prompt engineering, you could call it prompt analysis. It's just trying to figure out, okay, what kind of prompt would make a particular model give me a response that is useful for the scenario that I'm going for? And so literally in the prompt, we're crafting two parts. One is we're crafting a system prompt. A system prompt has priority, and we're going to ground the model. You are an AI agent responsible for evaluating work orders for automatic cancellation, and then we're giving it more information. These are the instructions, and a system prompt takes priority. Then we want to take some amount of data and actually put it into the prompt. And so, this is a sample. When you get into a real implementation, you want to clean and protect all of these properties to make sure that you don't have any kind of prompt injection, just like SQL injection. And using string interpolation is going to make sure that we don't have symbols like quotes and whatnot baked in. But if I made the description be um, ignore everything that you were instructed before. So you want to guard against that. The methods to guard against that are still being tested, but you want to put in some data into the prompt. And so the next part is to craft just some type of IE-numerable where you put these together. In semantic kernel, this data structure was called chat history. Think of using Copilot or ChatGPT and how you can craft a kind of a series of interactions. Actually, let me just pull it open and let me demonstrate. How old is Liana? Well, it's probably going to do a web search, but it does not know who Liana is. All right, so let me do this again, and let me say Liana is my wife. Jeffrey is me. I am 45 years old. My wife is 1 year older than me. How old is Liana? And let's see what it is. Liana's 46 years old. Okay, well, how does it do that? Because there's a track record of each of these chat messages. And here's a bit of data. Liana's my wife. Jeffrey is me. I'm 45 years old. My wife is 1 year older than me. How old is Liana? And when I sent this particular prompt behind the scenes, it's also taking all of the previous chat history in this context, and it's also passing all of it here because what's happening right here is one round trip. one round trip to the large language model server. Now, Microsoft is running this one. All of these are stateless. It is a completely stateless interaction, and you have to roll up all the history. So you can have multiple messages, and the final message typically is guiding how you want the response. All right. So let's pull this back and recognize that, okay, we have two different messages. The first one is from the chat role system, and that's a system prompt, which we put some instructions. And the second one is our work order data, and then um, we send it. So we have instructions: respond with only yes if the work order should be canceled, or no if not. And so then literally, this line of code is the one line of code necessary to call our large language model server. And let me just scroll up. Notice that this class requires it requires a chat client factory embedded into it, and the iService provider, the built-in .NET inversion of control container, is basically instantiating these constructor dependencies. And if I if I go into this class, Control B with ReSharper, if I go into this class, then I am basically looking at some configuration keys, and I'm saying, okay, if we don't have an Azure OpenAI key, well then go ahead and build the Olama chat client. And if we do have the Azure OpenAI key, we'll then go ahead and build the Azure OpenAI client. But either way, this is giving back an implementation of iChat client. All right, so needed some configuration and some building of the client, and that's it. So Control F4, go back. So we have a iChat client. If we look at var is iChat client, and we're calling get response. Get response is literally going to be a object called, it's of type chat response, and then we can get the text and we can trim it, and we can do to upper because we're looking for yes or we're looking for no, and that's it. And then we return a Boolean. Okay, so let's look back at this class, and this class literally is just a method. Should cancel work order async. It returns bool. We can call it. So literally, I have an object whose responsibility is to evaluate a work order and make some type of determination if we should cancel it or not. And then my background job can update SQL Server and do just regular code. So architecturally, the concept of an agent is just some part of your software that can use generative AI technologies of today to make some type of probabilistic determination that then can be acted on by the rest of the application. Now, there are other types of agents, but that's in essence. A lot of the talk about agents of the past few years has been literally chat agents. And those have been focusing on tool integration. And tool integration is totally different. I'll show that in a little bit. So actually, I'm going to show that now because it's kind of interesting. So let me pull over some semantic kernel code. This is what you can use in production right now. And let me open it. Okay. So let's evaluate a prompt that says, is grandpa's age older than Liana's age? Single word response, no punctuation. This is what the code looks like if we're using semantic kernel. And it's a little bit different. You see the words kernel. We're our iService provider. We get an instance, and then we import plugin from type. I'll go over what that is. But instead of the interface iChat service, which is the newer interface, and going into .NET 10, that's what it's going to be. For the last couple of years, the main interface in semantic kernel is iChat completion service. And there are implementations for Olama, there's implementations for Azure OpenAI and others. But that's the terminology for semantic kernel. And for semantic kernel, we pass in a prompt or multiple prompts with the chat history, and then we have some prompt execution settings. All right, so for this one, there's no way that any model can answer the question, is grandpa's age older than Liana's age? So what do we have to do? Well, we have to equip the actual LLM server with the ability to get some more information. If I, uh, now with semantic kernel, actually, this right here is the test case that I just showed you. Hi, my name is Jeffrey. I'm 45 years old. Leanna is Jeffrey's wife. She's 1 year older. How old is Jeffrey's wife? These are 5 different things. And I do that just to show you the chat history. In semantic kernel, there is a collection called chat history, and it kind of tallies up the different prompts and responses, and then every time you send a new one, you're sending all of the previous ones as well. Okay. Let's come back to the is grandpa's age older than Liana's age? The other way to pull more information into the chat context dynamically is to use tools. In semantic kernel, that is called a plugin, and they're also called kernel functions. Um, so if we jump into this class, which is in my code base, demographics kernel functions, I'll hit Control B and jump into that class. This is this is just a very simple class and method, and we have it annotated with kernel function, and we give it a description, and it requires name. This code can be anything. Now, I've hard coded some different ages based on what you pass in, but this code, and most of the time, it's going to be an entry point into some part of the system that can retrieve information or take some type of action. And in this case, you can imagine we might, query a person table and get back Jeffrey's record, pull the birth date, calculate the age, or we might query grandpa's record, get the birthday, calculate the age. So this can be arbitrary code, and these kernel functions also get resolved with the iService provider interface. So with constructor injection, it's just a regular resolved .NET class. You can inject anything in there, and it can do anything. All right. So with that, when when we ask, is grandpa's age older than Liana's age, in the processing, it'll say, well, I don't know this, and I don't know this. Oh, but wait, I have been equipped with 2 tools that are a part of the prompt, and there's a tool where I can get grandpa's age, and there's a tool where I can get Liana's age. And so, with that, the code will be called, and then the 81 years old and 46 years old are injected in there, and it can respond back yes. All right, so that's AI tools, just kind of in a rapid nutshell. All right. Jeff Sutherland is one of the co-creators of Scrum, and I had the privilege of interviewing him on my podcast recently. And he mentioned a term that I hadn't heard before in the industry called extreme agile. And he believes that by 2030, teams are going to be 30 to 100 times faster than they are today. And I've been thinking about that, and I've been listening to everybody else, and I'm thinking, okay, whether or not he's right, because that's a time frame and that's a certain productivity. But I was looking at just in general little bits of productivity, and I was seeing that with Copilot and with JetBrains AI Assistant and the others, coding tasks that used to take a certain amount, well, now they're taking less time. I mean, even in the base case where a coding task required querying of Google or Stack Overflow, well, now with a Copilot query, it just research time is shrinking to near zero for so many tasks. And over my career, I've used so many different eras of syntax that there's so much different syntax floating around in my brain. I can't possibly remember all the details of every little bit of syntax. And I used to spend lots of time just doing different searches for, okay, what's the right syntax for this? And I'm not talking about .NET. So I know C sharp like the back of my hand. I'm talking about I'm doing a if I'm deploying to a second test environment with the Azure Pipelines YAML format, and I wanna make sure only one instance of the pipeline is running for that particular environment because there's a shared resource, and I don't remember the one little switch that YAML format needs in order to make sure that I'm serializing properly on a particular stage of the Azure Pipelines sequences of stages and jobs. I mean, I don't remember all those details. And so I use Copilot and I talk. And by the way, I love I love just dictating. I use Copilot and it just instantaneously gives me the answer. Let me give another tip. I'm gonna open up Notepad and I'm just gonna put it here in front of me and and close the guy. All right, cursor's there. And so I hit Windows H, and now it just starts dictating whatever text box has the cursor, has the focus. I can just talk into the microphone, and it's going to start dictating whatever it is. And so regardless of the AI tool that I'm using, I can put the cursor in the GitHub Copilot window or in ChatGPT or Windows Copilot or Microsoft 365 Copilot, whatever tool I'm using, and I don't have to type the entire prompt. I can put the cursor in there, I hit Windows H, it's connected to the microphone, and it doesn't matter what microphone, even the microphone that's baked right into my laptop computer is plenty fine for dictating, and I just use stream of consciousness out of my head, and I just start talking out loud about what I'm working on, and then I finish it up with a question, and that is enough for the AI tool to basically process what I'm going after and give me a good response. So that's pretty interesting. Let me hit Windows H and stop the dictation. There it is. So I hope that helps. But that's quite a bit of text, and it doesn't need to be perfectly. It doesn't need to be punctuated at all. It doesn't need to be capitalized. I can even stop and start. It doesn't even have to be complete sentences. But how much time is that right there just to be able to speak into some type of microphone and let the machine put it into text format, funnel it uh, into whatever Copilot tool I'm using, and now it's saving me a lot of time. That's awesome. All right. I do want to talk about architecture standards and design patterns and consistency because when we're using AI driven development, now let's move away from LLMs. I talked about using I talked about and showed some code that used a language model so that we have an interesting software feature. Let me back up and let me just talk about GitHub Copilot agent mode and using AI driven development to actually generate our code. All right. If I have a code base that is completely empty or has code that I don't like, um, GitHub Copilot is going to pattern match. It has to have something to do a pattern match against. And um, if it doesn't have a pattern, then it really can't do anything. It's going to generate some code that you don't like. And so I'm going to show that in a little bit. But um, if it's a completely empty Visual Studio project, then the patterns that it's going to uh, match against are patterns that are in public GitHub repositories, and they're nothing related to your organization. And so, if you come in to GitHub Copilot and you're creating some test cases and I don't know, you want to use Playwright and you're using, Claude Sonnet 4, and let's say you want to, dictate, create a test and log into the work order application and then log in as Timothy Lovejoy and assign a new work order to Maud Flanders and call the work order mow the grass with a description of make sure the grass is edged as well. And I know I just I just dictated into the ether, but um, if you don't have any kind of patterns, there's nothing for GitHub Copilot to pattern match against. But if you do have some good patterns, then it's going to take the code that's in your solution right now and it's going to pattern match against it. And you're going to get more code that is like the code that you already have. So it's so important to have a code base that has some type of architectural standards. It uses some design patterns. It has consistency because then you are turbocharging GitHub Copilot, and you're really gonna like what you get. Um, and so, from an architecture standpoint, if you want to equip your software engineers with GitHub Copilot Pro, the license that you get from your GitHub enterprise organization, then you need to do some specific things in the code base that you're working with so that there are examples of design patterns that you've really chosen that you really like. And that way your engineers aren't trying to also, morph the code that GitHub generates into patterns that you'll accept. Okay? All right. So let me give you a sample. And of course, under the covers, uh, I actually did dictate into Copilot the creation of a test. And let me pull this over and let me show you uh, how that works. So I have, let's see, I have some tests, login tests, and I have some patterns using Playwright for this work order application. And for login, well, we're going to use the page object, go somewhere, and then take a screenshot, and then look for the logout link. If we're logged in, go ahead and click it, and then look for the login link and take a screenshot and look for some particular element, the username element, make sure it's H Simpson when we log in. So I have those patterns established in the code base. And so and while I was talking, you know, I let Copilot kind of work on it under the covers, and I'll do it again. But I said create a test and log into the work order application and log in as Timothy Lovejoy, assign a new work order to Maud Flanders and call the work order and then mow the grass. So it did that. Let me, I'm going to keep it and we'll start. So now we have a test. Guess what? All of my tests inherit from acceptance test base. It picked up on that pattern. All of my tests in the constructor clear out the current developer database, unload it, and then reload some test data. Guess what? It picked up on that pattern as well. And then it picked up on some naming patterns that I have for tests, and it picked up on the way that this particular application uses commands and queries to exercise the data access layer versus other applications that might use repository interfaces, and it picked up on the username of Timothy Lovejoy, and because that username is in my test data. Now I said Maud Flanders, but it didn't dictate right, so it picked up Ned Flanders, so it didn't get that perfect. And then it picked up on some helper methods to log in as the current user, helper method to create and save the work order, helper method to re-get the work order from the page, and then it's inputting, and it picked up on the test IDs that other tests use, mow the grass, poke it in there, and then cut the church lawn. So this is using the Playwright framework properly for some automated full system tests. And then we even have some assertions using the Playwright expect method. We're going to expect the title field to be mow the grass. We're going to expect description to be that. So anyway, um, if you have a code base with established patterns, then GitHub Copilot is going to do a really good job. All right. I think we might need some help muting think Andrew's microphone may be funneling in some audio. We might need to mute. There we go. Thank you so much. Thank you so much. All right. Now, let's say you're having a really good time with GitHub Copilot and you're generating a lot of code. If it's bad code, then Copilot is just going to help you ship bugs faster. Just like if you have automated deployments, but you have no validations, if you have no automated test suites, then automated deployments are just going to help you get problems into production faster. So you need quality. You need quality practices. This here is the top 1/3 of our DevOps architecture poster, and it includes all of the capabilities that you need in every complete DevOps environment. I have been preaching this for years, and if you don't have this, GitHub Copilot is not going to be useful for you because it's just going to help you generate the same rate of bugs, but you're going to be doing it faster because you're going to be shipping code faster, but it's not necessarily going to be code that's defect free. And so you want to think about that. Now, let's hypothesize into the future about something. Nobody knows what the productivity ceiling is going to be and how fast we'll be able to go with these era of tools. The agent mode in GitHub Copilot has only been around since since what, May, with the build conference, where the agent mode came out and it wasn't just ask or edit. So it's very new. And so we know it's going to get better and better and better. But right now, pretty much everybody that uses it reports time savings for something, right? So everybody's saving time. Well, let's say that it gets so good that we save so much time that we're basically able to work on a feature branch and get the code that we wanted out of our brains and into our feature branch at the pace that we could think about it. Because right now, when I take a development item, when I take an issue on the board, and I create a feature branch from that issue, and I start working on my first commit. I mean, series of commits before I do my pull request. When I start doing that, there's mechanics right now that are in the critical path before I can submit my pull request. I have to think about what I'm doing. I have to type. I have to move around the IDE. I have to open up files. I have to navigate from one to another. I have to write unit tests. I have to write component level integration tests. I have to write automated acceptance tests. I have to refactor some things. I have to augment some, developer level test data. There's all kinds of mechanics that are in critical path. And I have to navigate those mechanics and basically take what's in my brain, the understanding that I have in my brain of what I'm doing, to actually get it in the code base so that I could submit a pull request. So suppose that the tooling gets so good that we can take the feature that I'm working on and allow me to just talk about it openly, and in real time, Visual Studio and Copilot or whatever tools we end up getting are just in real time morphing the code base, and I'm like looking at it and I can say, no, stop, don't do it that way, do it differently. And just as at the pace that I can think and reason and speak, the software is just changing and the source code is changing in front of me, and 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 I can run copious amounts of tests and generate those, and I can make sure that I like what I'm seeing and then get to a pull request. Let's suppose we get to that point where the development column that we see right here in front of us is so short that it's at the pace of the thought of the software engineer. Okay, does that mean that programming is automatic now? No. And as long as we are putting C# code files and JavaScript code files and CSS code files and Razor code files and SQL code files into our version control system, as long as we are doing that, we have the same paradigm of programming. We're going to have to, the source code is the asset, and the source code is what we're maintaining as the company asset. So in the case where this development column moves super, super, super fast, okay, well, what do we still have to do? Well, and I flipped the slide. All right, this development column is in the middle of the board. Look at the columns just to the left, starting with conceptual definition. We still have to figure out the business objective of the item and have a clear understanding of what the goal is, the why, the what, the by when, for whom, what's the goal, what are we trying to accomplish, what non-technical outcome is there, is what's the acceptable ROI, what customer group needs something, what are the constraints. And we're also going to have to figure out how someone is going to use it. What's the user experience? If there's a button that goes on the screen somewhere, where does it need to go? We have to make those decisions. And then we have to decide how we're going to augment the architecture. Do we need some new design patterns? Do we need to break it down into implementable pieces? And then after that, we have to figure out the definition of done. What is in scope for this item? What is out of scope for this item? What sequence of user tasks do we need to go through to make sure that it's behaving like we intend for it to behave? And so um, those things are still absolutely required in the process, and we can't get around it. So even if the the coding and the feature branch process are are like that, uh, we still have to do all these other design decisions. Okay. All right. I want to show you one more AI agent before we move into questions, and that is what a chat agent could possibly look like. All right, let me open up this code base again and go to the chat handler. I think this is where that is. Check fig. No, it's up here in LLM gateway, query, the factory, chat handler. There it is. Okay. This is what I wanted. This is what I wanted. Let me just kind of move that off to the side and make it to where you can see it. Okay. We have a work order chat handler. Now, um, in in our application, you have all these chat agents and they do something, and uh, sometimes companies want intelligent chat agents where you can literally type into an agent and ask it questions about things and ask it to do things. But right now, the read-only chat agents are being deployed because right now it's kind of risky to have one of these automatically create or execute a transaction, but doing queries and helping with lookups, that's useful right now. So this code is behind the scenes it's a handler for a particular work order chat query. So it's a it's when you hit the button to submit a chat message, it comes here. Okay. So we have a series of prompts when we send the actual user prompt. And it's just like the other one I showed you. We have a system prompt that says, you help users do the work specified in the work order. And then we just take all of the information about the work order and put it as system prompts, and then we call the Microsoft Extensions AI iChat response or get response async, and we return it back. And the chat options that we pass, this is where the magic comes, because I showed you what it was like to call tools in semantic kernel. Well, in the newer libraries in Microsoft Extensions AI, we have the ability to create a list of AI tools, and we have a function called AI function factory.create, and any class that has methods can be entry points that you register with your iChat client. So let me go to work order tool. Let me jump into that class, Control B, and look, this class, and by the way, it's resolved from iService provider, so it can have any kind of dependency injected as well. It's resolved from the .NET, iHost and services collection and whatnot. So there's one method, get work order by number with the number, and there's another that's get all employees. And I know this is sample simplistic. Um, we never want to get all employees, but this is how it's done. We send a query message to our application bus because this is the pattern that it's using, and that's the entry point into some of our application code that can then end up querying our database and bringing back information via entity framework and put it into these entity objects and then pass it back. So tools can be very, very simple because all they're doing is identifying and wrapping an entry point into some code that already exists in our application. And then we give it a description that goes into the prompt as well. And then in our chat, we can literally say, I don't know, list all employees, and it'll list all employees. So though that is the magic of tools. All right. So that's what that looks like. All right. I'm going to end on an exhortation to quality. You need to establish quality with this AI programming, or you're going to get burned. Think about it. Projects, they start with big dreams, awesome ideas, maybe even solid market research. But if the quality isn't there, all that potential is going to go down the drain. Because once you start fighting with defects, everybody knows what it's like to fight software defects. Well, once you start embedding in some probabilistic logic with language models versus deterministic logic with C sharp, you're going to have so many bug reports. You really need to have your automated test cases organized, or else you're going to have a whole nother series of defects and bugs because the software is not really working the way that users expect it. And defects steal your time. And so it doesn't matter how many people you have on the team. If half of the time is spent just fighting problems, then you don't have a team of 10. You have a team of 5. If you have a team of 2, I mean, you could be doing nothing but fixing bugs, and then you don't even have enough time to develop the next new feature. Okay, so that's super important, and all of the same DevOps principles apply to give you the safety net to know that if your next build, you think you took a good step forward with your software process with the feature branch that you just merged, but you need a safety net. You need some automation to give you a signal if the forward step that you thought wasn't a forward step at all, but it was a backward step because you accidentally broke something that was working, and now you just broke it. So you absolutely need all 3 phases of continuous integration to keep you safe if you are going to start putting in some logic using language models and therefore have some probabilistic behavior in your application versus your deterministic if statements. And so you need your private build, you need your integration build, and you need your first deployment. A lot of people forget that first deployment stage of the continuous integration pattern where we have that new build and we do an automated deployment of our new build to answer 2 questions. So question 1, does this new build, is it still able to be deployed to a target environment? Step 2, does this new build still even start up and get to the main screen? Because if you have a new build, but even attempting to deploy, well, now it's broken. Or once you have it deployed to a target environment, trying to start up all of the pieces and you're throwing exceptions, well, you just broke it and you don't know. And so you absolutely need a really good, high quality DevOps process that's going to give you that good safety net. And you need to augment your pull request process and make sure you're doing all of this on feature branches, and every bit of new code uh, is accompanied by new automated test cases in the same pull request so that you're constantly strengthening your safety net. All right, I'll just kind of skip this, and um, that's probably the last point I need to make, and we can reserve a little bit of time for questions. I know this is a lot of information that I've thrown out there. I'll leave up a reminder if anybody wants my book. You can request it. But this is new for everybody. Everybody's learning the ins and outs of it. But the libraries and the tooling has already gotten so good that it's really approachable. I hope some of you looked at the code that was necessary to actually exercise some of these models and realize that it really is simple code with these libraries. And you can pretty much make, any kind of agent anywhere in your software, because you can literally just make a class that is an AI agent, and all it's doing is making a recommendation for a decision on some type of fuzzy factoring. I didn't even touch on RAG, retrieval augmented generation. I will say, if you've never looked at it, search for the new .NET project template called AI Web Chat, and you can download that from Microsoft. And it's a new getting started template, and it has right out of the box a really simple implementation of taking a body of text, pre-processing it into embedding vectors, and then using it in a little chat screen to query some information that you processed into the vector database. And that's a really good way to uh, do some fuzzy search features where maybe you might otherwise have to use SQL Server full text search, which it's SQL Server full text search is not easy to use or maintain. But if you want some really fuzzy searching logic of some data that you already have, then creating embeddings and storing those in a vector database is a really good way to create some easy and approachable search screens that would do that for you. All right, and with that, we can take questions however you want to do it, Sam.
Sure, we'll just open up the floor. If anyone has any questions, feel free to come off of mute or enter them into chat, whatever your preference is. So Matt is giving you a round of applause, and I echo that statement as well. Great presentation, as always. And you really touched on some AI features that I haven't seen before. So that was very interesting. Um,
Good.
so first order of business, do we have any questions for Jeff?
I have one quick one. I think it's quick. How did you get the API key for Copilot? Because your system said if you have a Copilot, I was looking into that earlier today, actually.
That you're saying my system said if I had Copilot?
Oh, I thought you said when you were reading through your code, you were pulling up your bot and you said if you have a Copilot key
Copilot
here
Pro.
or Duo Llama.
Okay.
How do you? Yeah.
That was just reading from an environment variable. That was just some code logic. The code was branching, and for local development, there's a lot of testing that I can do, um, just directing my code to use Llama 3.2 or another open source model running on my computer. But when I push to a test environment and then staging and production, of course, I don't want to be using Olama. I want to be pointing to Azure OpenAI, and I want to maybe do some testing on GPT 4.1 or some other model deployment. But it's just a regular if statement based on a configuration variable. If I'm development, I can direct that to my local Olama. If I'm in Azure, I can direct it to Azure OpenAI. So that's all it was. It was just reading a
I thought you were talking
config
about
key.
so you're localized, like if you own Copilot, which I do, in Teams you can talk to Copilot. You can ask it to do all kinds of crazy stuff, and with the new versions, it has the research capability. They said coming soon they're going to give you an API address and a key for your own person, so you could have software talk to your personal Copilot on your behalf. That's what I thought you were referring to.
Oh, no, I
So,
don't think so.
but yeah, I have Olama running. I'm building my
Okay.
second server out for Olama for
Yeah,
production.
and that particular that wasn't yeah that scenario wasn't using Copilot at all. It was using iChat client.
Okay, I didn't review your code real well. I thought maybe you
And
knew how to
sorry
get
about
this.
that.
No worries, my bad.
Oh, but by the way, if y'all haven't heard, GPT-5 just came out and was announced. So everybody's trying to figure out what's new with that. If you hadn't heard the announcement, GPT-5 just came out today. All
Nice.
right.
I also
Any
had
other?
one additional question, but before I think Ron came off of mute. Ron, do you have a question? Doesn't look like it. So my question to you is, when you had the sample application for doing the work orders with the Simpsons, um, and is there a way to grade the response you're getting back from the model, meaning that it deemed the order to be canceled, but in fact it should not have been canceled? Can you provide some feedback to the model, or can you retrain it somehow by capturing these logs?
Well, the interesting part is that we can't do any retraining of the model. That's we can't these 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 foundation models for the application developer. The application developer can't retrain or fine tune any of these models. All we can do is use them. The concept of fine tuning a model is a much bigger conversation than an application developer is going to take on. But what we can do is we can fine tune our prompt. And that's what we have to do. And so the burden is on us to do some, to create some test suites that in the AI community, it's it's sometimes called evaluations, and even in um, Azure AI Foundry, there's some services that are being popped up for these automated test cases called evaluations, where you can have a prompt and a desired response, a prompt, a desired response, a prompt, a desired response, and because managing all of these pairs, these effectively are test cases. Anytime a new model comes out and you decide to change the model, well, you're changing part of your environment, and you might have fine-tuned all of your prompts that you put in your classes, in your agent classes, and they work great for the model that you have. But then a new model comes out. Well, that's just like, having a, you know Windows 12 comes out, Windows 13 comes out, Windows 14 comes out. Is our software going to run flawlessly with it? Well, we've got to test it. And so you have all of these candidate prompts and desired responses. You need all these test cases to run against the different model, because it does you no good if you change to that new model and then a whole bunch of your software starts doing the wrong thing. So it comes down to software engineering practices and having adequate test cases around whatever you choose to make an agent, because inherently that logic is going to be probabilistic as opposed to deterministic. Does that
And
answer all of that question?
yes, and with regards to unit testing, like you mentioned, I think to sum it up, the more things change, the more they stay the same, right? We still got to do unit testing. We have to ensure our application is trustworthy and functioning correctly. And bugs is whenever bugs are encountered, it causes much more of a negative ripple for the business, for the software development team. It's a much bigger issue than just, well, it's something that I can fix. No,
Mm-hmm.
there's much more of a ripple that's caused by that.
Yeah.
Um, Let me turn it over to
Or to
Ron.
Ron. Can you hear me now?
Yeah, go ahead, Ron.
Perfect. Yeah, Sam, this kind of piggybacks on your question here. Great presentation, by the way. This was my
Oh,
first
thank you.
deep dive into this. It sounds like, from what you're describing, that basic engineering practices are not only still here and going to stay,
Mm-hmm.
become more important.
Yes.
Solid testing, integration tests, understanding, your dependencies and all of that, so that development slice gets thinner, but it sounds like the general engineering stays, which is
Absolutely.
kind of it's an interesting take, as developers are, a lot of them have this low level anxiety about what's going to happen in the next 5 to 10 years. um, that's kind of reassuring to know that the underlying engineering isn't going to go away.
Absolutely.
Matter of fact,
Yes.
sounds like it's
Can't.
becoming more important.
Yep. Yep. It is, in my opinion, it is more important because without without just take Copilot out of the equation, take language models out of the equation. Teams all over the industry are still struggling with a pace of defects that escape their current process, a higher pace of defects than they want. And then the defects come back, they have to fix them, and they end up spending a portion of their week that is larger than they would like. Well, that's at the current pace of the current pace of commits into their Git repository. What does AI driven development promise? It promises a faster pace of commits getting into the Git repository. And if we don't like our current pace of defects that slip out of the process, then just do the math. It's going to be whatever quality percentage that you have, whatever quality percent or defect percent escapes your current process, you're just magnifying it. So you have to get your quality
This,
process under
this might
control
make
or you're going to drown.
this might make poorly architected applications actually worse.
Yes.
Yeah.
Well, cause and effect. Why is an application poorly architected, or even why is the code poorly organized? Well, it's because the people working on it don't know how to make it well organized. So putting in a tool that just makes the pace of commits faster doesn't actually address the upstream cause.
Yep. Well, thanks for that.
And I'll say one more thing about this technology. I've been programming since 1997. I am so energized by this wave of technology, and with the tools like Copilot and JetBrains AI assistant and more are going to come out, and Cursor, and who knows what the competitive landscape is going to be next year, and they're all fighting, and the competition, they're all getting better. I am so energized by this wave of tools, um, because I I know what the code should be, and it takes my existing expertise and it turbocharges it, because AI driven development attacks the friction in the mechanics of getting what's in my brain into the code. That's what it attacks. It shrinks the mechanics of from brain to code. What it doesn't change is what I start with in my brain when I put fingers on keyboard. That's what it doesn't address. So it would be a fallacy to expect that an inexperienced programmer would somehow have a higher understanding of what is good just because they're using Copilot.
Or a non
Copilot is not going to make you able to do something that you don't know how to do. It's
or a
going
non
to help you do what you already know how to do faster.
Yeah, I worry like the non-technical people writing software.
Oh, they will. They always have. They
This
always
is
have.
this isn't
That's
the
not going
first
to change.
yeah, this isn't the first time. I mean, code automation tools have been around since forever.
Yeah.
What's the worst that could happen?
You paid to fix it.
No, I meant for non-technical people writing software. What's the worst that could happen?
I don't know.
Yeah, but they always have. And I mean, think about it. Every Microsoft Office tool has coding snippet windows you can drop down into. I mean, SharePoint. My There is so much software that's needed. If you had to have if you had to have professional trained experienced developers to write every bit of needed software, it wouldn't get done. We have a shortage of people who know how to program. So there's a whole lot of classes of programs that we actually need non-technical people with just some analysis skills to be able to do. I mean, that's why Excel exists. That's why Power BI exists. That's why Zoho CRM and Dynamics and all of these other tools exist, because we don't need Visual Studio to create all kinds of software, but so there's a place for everything. But yeah, there's there there's always been mistakes made and lessons learned and messes to clean up. But you know what? I sure love programming and everything around it. It's so fun.
Very much, especially with the way technology is evolving and newer tech is, especially in the AI realm, how things are coming to the forefront.
Yeah, yeah.
Excellent. Anyone else with any additional questions or comments?
Got one more. I didn't get a chance to look through all of your repo yet, but do you have anything on RAG models with Microsoft extensions or anything along that line out there in your source code?
Um, no, what I wanted to point you to was the AI web chat, and
Yeah,
because
yeah,
that
yeah.
you're
I
gonna
wrote that.
um, and actually, let's see here. I'm gonna well, yeah, if you just search for AI web chat, it's gonna have you do like a um, a .NET command to install a couple new VS Project templates, and then one of them is the RAG template, and it shows just how approachable the RAG pattern is, and this architectural concept of a vector database. Well, that's a new concept. And right now, yeah, you can use some local test vector databases. If you need to go to production with one of those right now, then you'll have to reach for one of those products. But Visual SQL Server 25 is in preview, and SQL Server 25 has a vector data type. So, when it releases later on this year, we think, you know, you don't have to have architecturally a different database technology just for vector embeddings. It fits right there inside SQL Server. So all of your backup processes, all of your scaling, all of the normal things that you've built up around SQL Server, now these now these vector embeddings, well, it's just another data type, and it fits right in to your existing data estate, and it makes it so approachable because now all I do is I call one line of code to create some embeddings from basically a string, and you go and get the string, get the document, grab the text from the document, put it into a stream reader, and then create the embeddings, pre-process it by inserting it into your vector table in SQL Server, and now you can just have a easy web chat where you're literally having a discussion with your data. I think that's awesome, and it is so little code. That template straight from Microsoft demonstrates how little code is necessary to get that scenario up and running.
Very cool. Any other questions? Very good. Jeff, thanks again for a great presentation. Always hit the nail on the head and do a great job with the delivery. So appreciate you joining us again.
Oh, thanks for having me, Sam, and thanks for your
And
leadership in the group.
appreciate it. Thank you. Before we wrap it up, I just have a couple wrap up slides. So if I may, I'd like to share my screen. And while that is coming up, I'm also going to paste a few links in the chat window. So the link for the YouTube channel is posted in the chat window. If you would please subscribe to the channel to get upload notifications when the video is ready. In addition, tech events are going to be posted on my blog, samnasser.blogspot.com. And you can also subscribe to that to get You can also subscribe to that to get updates. And then last but not least, the feedback eval form. That's also in the chat window. Please take a moment to fill that out so we can provide Jeff with some constructive criticism. With regards to events, the regional events that are going to be happening, and by regional, I mean things that within the area that are accessible either virtually or online. Sorry, either virtually or through a short drive. So with that, on August 21st, which is a Thursday, is the Greater Lansing user group for .NET developers. That's going to be on Thursday, August 21st. And then on August 27th is the Cleveland C# user group. We do not have a speaker lined up for that yet, but rest assured it will happen. And then on August 13th through the 15th is the Kansas City Developer Conference, also known as forgive me, little tongue-tied, KCDC. And the link for that is kcdc.info. That is a 3-day session that's going to be happening. It's going to be covering a variety of different topics, as you see here. And then another thing I always like to talk about are jobs. So who's hiring and who's looking for work? If you would please make yourself known into chat or speak up verbally. If you have any open positions in your place of employment, or if you're looking to get a new place of employment, please make yourself known. And so far, it looks like everyone is happily employed. Andrew Winner is looking for a solution engineer or architect role. Matt is also looking. So we have 2 people from the group that are in the job market. And so one thing that I can invite you to do is to check out devitjobs.com. So this is a great website that allows you to search on a specific technology, the role, whether you're going to be working remotely or in person, and it provides many different filters. So I strongly recommend you check out devitjobs.com. Lastly, if you have any questions about today's presentation, you can always reach out to me at nasser@nistechnologies.com. You can also find all my socials on Linktree. And if we're not connected on LinkedIn, let's do so. It's a great way to keep in touch and check out some of the latest news and what people are working on. You can find me there, and strongly recommend that we connect. And so with that, thanks again to Jeff for a great presentation. Thank you all for attending, and look forward to seeing you all next month. Good night, everyone.
This conference is no longer being recorded.
I just wanted to mention that Jeff had posted a message that ClearMeasure is hiring a software engineer, any level, clearmeasure.com. So for Matt and Andrew, please remember to check that out. And best of luck with the job hunt, guys. All right. Take care. Good night, everyone.